Hello everyone, this is Partho Das, your electrical machine 2 lab teacher for this particular lab. So the subject name is the electrical machine laboratory 2. So subject code is EE591, and today we are going to perform the experiment load test on single phase induction motor. Now, we know that single phase induction motors are widely used machine in all over the world. Now, the single phase induction motor has a variety of applications. It can be used as a fan that we actually use as a stand fan or ceiling fan, whatever fans we use. In refrigerator for the compressor purpose, we use this kind of machine. For the washing machine, so for different purpose applications we have in case of this induction motor. But there is some disadvantage with this single phase induction motor, that is it is not a self-starting machine. So there are different methods are available in the market by which we can start this single phase induction motor. So as we have the as we have the capacitor start method, we have the split phase method, we have the shaded pole method. But in commercial purpose, in our daily life, we actually use the capacitor start method. So whatever discussion we will do, whatever experiment we will do, we will do with a induction motor which has a capacitor start method. Okay, and by using that we will make a torque that is actually capable to rotate the single phase induction motor. Now coming to the experiment, so single phase induction motor load test, why we perform this test. So basically we perform this test to find out different characteristics. Why we need to find out those characteristics? See, we have seen that the single phase induction motors are widely used. So the single phase induction motor can be used at different loads. Now we have to understand as an electrical engineer that what are the different load condition at different load, maybe half load, full load, light load, heavily load, overloaded condition. So for the different load condition, what are the characteristics, what are the parameters value it appears in case of single phase induction motor, so that we can understand that within which range we have to operate a single phase induction motor, so that the efficiency, output, everything should be at our desired level. So from after completion, so what we will going to do, so in this experiment we have a single phase induction motor that is connected to some sort of belt and pulley setup. So in through that belt and pulley setup we are going to change the load, and with the changing of the load the motor will try to keep its speed constant. So what we will do, the motor is facing some force. Okay, we are giving some force that so that it cannot rotate. But the inherent property of any machine is to it will remain it at its constant speed. So what it will do, so it will uh, consume more current from the source, so that so that it can make its constant speed. Okay, excuse me. To do that, what we do, uh, we connect some voltmeter, some ammeters or wattmeter with the system, and continuously we increase the load, and we will see what is the output of the system. And from there we are going to calculate the efficiency output power of the system, torque output power of the system, line current, the current versus output power curve, power factor, output power curve, slip power factor curve, torque power factor curve. So different curves we are going to understand. So this is all for the today. So let us see what is the experiment. Okay, thank you.